In this video, we'll talk about complex solutions to quadratic equations. They are very similar in scope to the normal expression for a quadratic equation when you are solving quadratics. To remind us what that looks like, it's this thing. So the only real thing to keep in mind is that, recall, we in complex variables now know of this thing called I, which is square root of -1. So no, whenever we're solving a quadratic, even when we're using this, if we ever get to a negative number on the inside, we can simply keep evaluating it with an I. For this example here, it would serve best to factor out this expression before using quadratic equations. So I can factor this out by doing x plus 3 x squared plus 9. So right away, one of the solutions would be x is equal to -3, but that doesn't exactly work all the time because we're doing a cube root here and we want it to be positive in the end. Anyway, so you have -3 from this solution when you set it equal to 0, and then when you set this equal to 0, it's a normal quadratic, which you can solve using the quadratic equation. Keeping in mind that whenever you have a negative in the square root, we can evaluate it further by simplifying it as an I. So another important concept when talking about this would be the discriminant of the quadratic equation. The discriminant of any quadratic equation looks like this. B squared minus 4ac. This is also, recall, like this is the same thing as the inside under the radical for the quadratic equation, b squared minus 4ac. So whenever the b squared, or whenever the number underneath the radical is 0, there is only going to be one real solution because we just have the number out in front and under 2a. If it's positive, then we get two real solutions. This is what we're used to in normal algebra or mathematics. And when it's negative, that's when we get complex solutions, as I was kind of alluding towards earlier. You would solve the quadratic very similarly, only knowing that when there's a negative discriminant underneath, or the negative number underneath the radical sign, then that would give us two complex solutions rather than two real solutions. So let's practice by solving for some discriminants. So right here, I could identify this as B. I can identify this as A and C. So if I do square root of B squared minus 4ac, 4ac, this is the square root of 16 minus 4 times -3 times 2 is equal to the square root of 16. This is 2 times 4 is 8, and 8 times 3 is 24. So what's a -3? So this would be plus 24, which 24 plus 16 is 40. So this discriminant is the square root of 40. I would go ahead and practice yourself on example 2 before I click over and see what we've got. All right, let's see what we got. Noise. So we found out that the discriminant was 40. Don't need it underneath the square root because I think the actual definition doesn't have a square root. It's just b squared minus 4ac. Awesome. On the second one, you should have gotten negative 23. We get this by labeling B as 1, A as 3, and C as 2. So I'd have 1 minus 24, which gives me negative 23. Since it's negative, that means that our quadratic is going to have 2 complex solutions as answers rather than when it's positive, we'd have 2 real solutions.